temperatures and seas, massive droughts, changing landscapes, successfully adapting to climate change is growing increasingly important. For humans, this means using our technological advancement to find solutions, like smarter cities and better water management. But for some plants and animals, adapting to these global changes involves the most ancient solution of all: evolution. Evolutionary adaptation usually occurs along timescales of thousands to hundreds of thousands of years. But in cases where species are under especially strong selective conditions, like those caused by rapidly changing climates, adaptive evolution can happen more quickly. In recent decades, we've seen many plants, animals, and insects relocating themselves and undergoing changes to their body sizes and the dates they flower or breed. But many of these are plastic or non-heritable changes to an individual's physical traits, and there are limits to how much an organism can change its own physiology to meet environmental requirements. That's why scientists are seeking examples of evolutionary changes coded in species' DNA that are heritable, long-lasting, and may provide a key to their future. Take the tawny owl. If you were walking through a wintry forest in northern Europe 30 years ago, chances are you'd have heard, rather than seen, this elusive bird. Against the snowy backdrop, its plumage would have been near impossible to spot. Today, the landscape is vastly different. Since the 1980s, climate change has led to significantly less snowfall, but you'd still struggle to spot a tawny owl, because nowadays, they're brown. The brown color variant is the genetically dominant form of plumage in this species, but historically, the recessive pale gray variant triumphed because of its selective advantage in helping these predators blend in. However, less snow cover reduces opportunities for camouflage, so lately, this gray color variant has been losing the battle against natural selection. The offspring of the brown color morphs, on the other hand, have an advantage in exposed forests, so brown tawny owls are flourishing today. Several other species have undergone similar climate change adaptive genetic changes in recent decades. Pitcher plant mosquitoes have rapidly evolved to take advantage of the warmer temperatures, entering dormancy later and later in the year. Two-spot ladybug populations, once comprised of equal numbers of melanic and non-melanic morphs, have now shifted almost entirely to the non-melanic color combination. Scientists think that keeps them from overheating. Meanwhile, pink salmon have adapted to warmer waters by spawning earlier in the season to protect their sensitive eggs. And wild thyme plants in Europe are producing more repellent oils to protect themselves against the herbivores that become more common when it's warm. These plants and animals belong to a group of about 20 identified species with evolutionary adaptations to rapid climate change, including snapping turtles, wood frogs, knotweed, and silver-spotted skipper butterflies. However, scientists hope to discover more species evolving in response to climate change out of 8.7 million species on the planet. For most of our planet's astounding and precious biodiversity, evolution won't be the answer. Instead, many of those species will have to rely on us to help them survive a changing world or face extinction. The good news is we already have the tools. Across the planet, we're making on-the-ground decisions that will help entire ecosystems adapt. Critical climate refuges are being identified and set aside, and projects are underway to help mobile species move to more suitable climates. Existing parks and protected areas are also doing climate change checkups to help their wildlife cope. Fortunately, it's still within our power to preserve much of the wondrous biodiversity of this planet, which, after all, sustains us in so many ways.